Select the best reagents to accomplish the following transformation. So looking at this reaction, the starting material for the reaction is an alcohol, and specifically that alpha carbon has bonds to two other carbon atoms. So this is a secondary alcohol. And we are being asked the reagents, and we are given the product, and we see that the product goes from a secondary alcohol to a secondary alkyl chloride. And the other thing that we want to notice is we want to notice the stereochemistry for this reaction. So we can see that the chloride has ended up attached exactly where that alcohol used to be. And so what that means is that we've had retention of stereochemistry in this reaction, at least overall. So we need to think about our reaction conditions here really carefully. So if we have in conditions A, and I don't usually go through all of the options, but this is a question where I think we're going to have to. So if we look at options A, we have a strong acid, and it's hydrochloric acid. So hydrochloric acid, the chloride ion is not as good of a nucleophile. So sometimes you'll also see the zinc chloride in there as well. But overall, a secondary alcohol with a strong acid, this would give us SN1 conditions. And SN1 conditions would lead to racemization, meaning it would give you a mixture of stereoisomers as the product. So we don't want to take that one. Okay. If we move on to B, if we have thionyl chloride and pyridine, the first thing that happens there is your alcohol reacts with the thionyl chloride to get a good leaving group. And then the step where the chloride attacks is an SN2 step. So this reaction overall gives you inversion of stereochemistry. So we don't want to use that one. All right, and then on to C and D. So these are both two-step processes. So if we look at C, in the first step, it's going to give you the alkyl bromide, right? Because we're reacting this with PBr3. And much like this reaction with thionyl chloride, that is an SN2 reaction, so it gives you inversion and transforms your alcohol from a bad leaving group to a good leaving group. And then when you have a good leaving group, in the second step, you're adding in a nucleophile, and that should do another SN2 attack. And so this will lead to inversion. Well, if you do inversion of stereochemistry twice, you're going to overall get the retention. So this looks like the right answer, and let's draw through these reaction products so we can see, at least follow the stereochemistry. So here is the secondary alcohol that we start with. And so if we treat this with PBr3 and pyridine, I'm not going to draw the mechanism this time. I'm just going to draw the overall result. And so the overall result would be the bromine would be attached to the opposite side of where the alcohol was. So that means that we would have this. So the bromine on the dashed bond, and that should have been a hydrogen, and the hydrogen sticking out. And then if we treat this with chloride ion, which is what sodium chloride just provides a source of Cl-. And so here's the step that's going to take the stereochemistry back again. So if that bromide is going into the plane of the page, the chloride is going to be attacking from the top of the page, which would lead to that desired stereochemistry that we see in the product. So hydrogen and chlorine.